This time on Captain Chaos's laboratory, we're going to be working on an Octo-swing. This just arrived in the mail, and one of the pods has been disconnected, and his head's flopping around, which is never a good sign. We got the wire here. But the problem with it is they don't swing out. So, if I turn it on, that's it. They just rotate. The lights work though, and the sound works, but this light doesn't work. And this light doesn't work. And this other light doesn't work. And that's probably because the wires are severed. So, it is a self-resetting unit. Even though the arms aren't out, it's going to keep spinning till it feels that it's ready, and then it's going to stop. Like that. So this is one of the units you do not want to turn off from a master switch. So, since the arms aren't swinging out, I know the mechanism that's not working is going to be in the top. There's nothing in the bottom that's going to make the arms swing out. So, we're going to start with the 3 screws right here. Try not to lose the screw. The other screw. There we go. There's all 3 screws. Now I'm going to try and feed these wires through the little hole in the center. And there we go. So we got a couple of lights that protrude through. One there, and then it looks like the other ones go into the tentacles to make them glow. I don't see any holes or divots for this one, so this one probably does go up into the head. The problem is where's the power connect? I see no power connections anywhere. So I'm wondering if these were spliced or soldered in at some junction. And then these other 2 lights, or one light, sorry, this is just a solder blob, were up inside the head to make the head glow. I'll have to look at it online, a picture or a video of the unit working to make sure that that's a correct assessment. So, this plate is the mechanism that's supposed to help tip these. So let's see what it looks like running without the top on. Give me a second. I just don't want the wires to get caught. Looks like that motor is bad. This thing sounds like it's in distress. This motor's not turning at all. The band feels fine. You see all the gears moving. They're right here underneath this lip. If I spin the pulley, the gears are moving. So let's take off the next layer. So the next layer looks like it's these outer 4 screws plus these inner 3 screws. using my finger to guide the screw up so it doesn't fall down the hole in the center. So I'm not sure what's down there. And I didn't unplug the unit. All I did was turn it off. So there's technically still live power somewhere within inside this unit. And now we're going to feed this disc out through the wire. So. And that might be the problem why it doesn't spin. Broken wire, red wire. But while we have it up, you can see the plastic race is grinding itself down right here. We got black on the gear. So that might need to be addressed. And this gear, oh, here's the shaft. So this gear doesn't have a shaft, but it just got stuck on the other side. So I'm assuming the red wire was right here under this glue blob. Apparently they insulated it by putting a glob of glue on top of the solder pads. So turn on the soldering iron and see if we can get this glue off and get back down to the contact. Right there, small itty bitty contact. It's either a contact or it's a pass through. It's hard to tell. There's one easy way to tell. I'm just going to take the whole top off. It's the contact. There's the rotor. It's got some green on it. That's never a good thing. Green is is basically verdigris. It's where the copper and brass meet and has a reaction with the moisture in the air. These are the guides. They're worn down pretty decently. It used to get used a lot. Here's your other motor. This should be the motor that spins it. So you got your guide wheels, and then these three fingered plates are the rotor, where it transfers energy from the bottom to the top through that rotor plate. So technically we should see this move. There's the impossible gear. So our lights are working, we got the gear spinning, we got this pulley going, but I'm not liking what it's doing to the band. I don't know if you can see it, so I'm going to move it center-ish and then try and zoom in. The band is pulling itself inwards. Where's my zoom? See if it'll refocus. Voila. Do you notice what's happening with this band? Instead of it staying in a straight line, it's pulling itself in and then going back around. The band is probably stretching or getting worn out, and it can actually get caught once it stretches enough that this side hits this side, that it'll pull the band in and wrap it around this smaller pulley and just wedge everything. Nothing will function. So we're going to have to address that band. So it's turned off. It's going to spin the gears until it engages the micro switch that says it's recentered. Like that. So I'm going to switch this band for this band and see if this other band works better. If not, we'll just replace the whole thing. It's not that big of it. Oh, that's all sticky. That's why it's doing that. It's like stuck. Much better. You notice that band's not pulling itself in. This band, wherever it goes, right there. Focus. this band, yeah, it's not going to focus at this distance, is sticky. And that's why it's sticking inside the pulley. So it's going to need a belt. Not a big deal. Easily done. Especially since we're at this stage. But one thing I do keep hearing, and you might pick it up on the camera too, is I hear a clicking sound. Clicking sound is usually indicative of a cracked gear. So there's a handful of gears underneath this edge, and one of them might be cracked. Turn it off. Looks like there's approximately 4 screws that hold this thing in. The reason I say approximately is sometimes these screws will hold in the rotor fingers, or whatever they're called, rotor contacts. They just remind me of 3 fingers curled like this. May pass all the way through this black plate into something else. So if they don't, then it's just the 4 screws. If they do, then it's going to be 6 screws. Bear with me for 1 second. Alright, so the screws are out and now I can lift it. Can't lift it a lot because there's a lot of wires in here. Trying to get my finger under the edge. There we go. You can kind of see we got a 10-tooth, a transfer gear, and the impossible gear. So I'm going to check them out and see if any of them are broke. There's a lot of lubrication in this thing. So, since I don't have a lot of room to play with due to the wires that run to the bottom or base, I'm going to put on some magnifiers and I'm going to manipulate this gear. See if this 10-tooth is cracked. It's not. I'm going to rotate these. The only thing I see is a piece of debris right here. I don't know if that's the clicking cause or not, but we're going to remove it. Put it back together and we're going to turn it back on. You recommend that you put the screws in, since if you don't, it's possible that this plate could lift and then you would have your gears come out of alignment, which means they either fall into center, possibly break, or just stop the unit from rotating until you realign them. And make sure you recess the screws. They're designed to be below the surface of the black plastic because of that top piece rotating all around it, because that's what these 3 wheels are for. So make sure that they're not proud of the plastic. Do not over tighten them where you break the plastic, but just make sure they're snug and that they are at the same height or slightly below the plastic disc. not hearing the clicking anymore, and that belt's doing a good job. Oh, there's the clicking. I think that clicking's coming from the bottom. It is. It's coming from the bottom. There must be a relay or something in the bottom that's making the noise. So turn it off, let it reset. We're going to clean up that disc, resolder some wires, and throw a new belt on that motor and see if we can get this thing to rotate again. But while it's out, I'm going to re-adhere this. Make sure it's facing the right direction. Like that. There we go. So that's popped back in. Alright, so I'll pause it here for a moment. I have a delivery that's arriving, so I need to go sign for it. Other than that, we'll be back in a moment. I'm going to clean off that rotor, solder the wire, change that one belt. We're going to see if this thing does what it's supposed to do. See you in a few. Alright, we're back. I went ahead and cleaned off and re-lubricated this with dielectric grease. You can see all the green's gone. I also cleaned the fingers, 3 fingers and 3 fingers. But at the same time, when I cleaned it, I went ahead and soldered the wire back in place. So the solder's right there. It's the shinier of the two. There you go, shinier of the two. And put the screws back in because I was tired of all the gears falling out and then having to put them back in multiple times. So it just became tedious. So I just put the cover on with all the gears so that way they don't keep disappearing on me. Next, we need to replace the belt. So I'm going to pull out my little belt kit here that I get from Skull Crane, which is always linked below whenever I use this stuff. And we're going to pop on a new belt. Nice. So now we have the new belt on, so when this goes, these guys will start to swing out. And this belt's still good, but I'm going to change it to the new style belt, the black one, just because I find they work better. There we go. And still spins. So the reason I check that is sometimes if the belt's too tight, it'll not spin, or it sometimes can walk off of the pulley. Generally the animatronic belt kits won't have that problem, but you never know. Sometimes you put things together and then they end up breaking just because it was a defective part. So I like to test it, make sure that it works, and there's no issues. So the next thing is once I get the top back on, we got to figure out these wires. You know, there's a junction right here, and we have an LED right there, I think. Now, these are just soldered junctions that they're using clear glue to control. So, but we know that they power something on the top, probably the lights inside the head. So, let's get this top back together. When you put it on, make sure it drops into place. You saw when I moved it, it dropped by itself. You don't want to force it. You just want to spin it until it drops over the impossible gear. And then I'm going to make sure that my wires are clear of everything. Yeah, I don't see where they're going to catch anything, since this does rotate. And next, we're going to put the top piece back on to hold it, and then we're going to try it out. We're going to make sure the belts do what they're supposed to do, that the motor spins like it's supposed to spin. You know, test it before it's reassembled. I'll have to say that so far this one's pretty easy to take apart if you have it and you're having problems. It's not terribly difficult compared to some of them. What I'm doing at the moment is I notice the belt's at an angle because this pulley sits a hair too low. So I'm just trying to raise the pulley so the belt's straight, like that. Alright, let's make sure this doesn't get caught in anything. And turn it back on. Alright, so I'm either not getting power to the top or it's wedged. Because this not turning. So and that's why we test it. I'm going to try it again without the belt now to see if it's bound up or if it's the power. So. No, this pulley's not turning at all in the motor. One thing I have noticed about this unit uses a clutched gear, which is the second time I've seen that on a Lemax. It's a gear that has a spring in the middle that if something happens, the spring will either stretch or compress, allowing for slippage, so you don't break your stuff. I can't remember the other piece I saw it on, but this is only the second piece I've ever seen them use that style gear, so it's kind of impressive. Because when I saw it the first time, I said they should do it more often. We'll have less of these that break. So, our joint's good. I'm going to remove the whole top, and I'm just going to do a voltage test on those fingers to make sure that those fingers are pumping out the right voltage. Or a voltage. Yes, technically I don't have to unscrew those. I know the motor's not bound up. So I want to see if these are putting out correct power. A little excess grease there. Yep, 4.3 volts. 4.4. Go up to the fingers again that actually make contact with the rotor. 4.5. So I am getting good power up to the rotor. Now we just got to figure out why the rotor isn't conducting it to the motor, or if it is, it has a bad motor. So double check the solder joints. That's the wires for the motor right there. And make sure they're good. They appear to be okay. I'm going to remove these solder balls. We'll do it correctly if they need them. Okay, there we go. It was spinning for a second. So it looks like I'm having a connection issue because it only spins when it hits right here. So those fingers either aren't riding right or maybe that's all it's supposed to spin. I don't know. I'm watching which way the gear spin or the pulley spins. It's reversing directions every other time. So let it stop. Okay. Okay. I'm going to go back to the original belt and see if that's the problem, that the new belt's just too tight. No, it's trying to turn, but it still can't turn under a load. So I'm watching all the gears, trying to figure out why it's not working. I'm leaning towards a power issue. It's not transferring into the rotor good enough. I'm also watching the outer plate that swings these out. The gear is turning, but the plate is not. Sorry on a boring section here. There's a huge gear reduction, so one revolution here is about a quarter of a tooth there. And they're starting to move out finally. So the gears are working like they're supposed to. So one of two things. Either got a bad motor or bad contacts at the rotor. So I'm going to test the motor. Yeah, so she's coming out like she's supposed to. Oh, let's pull the top off again. Like that. Okay. I go to ohms, and I want to test across the motor. I should be getting something. I'm getting 0 across that motor. So I should be able to test the magnetic windings inside the motor. I'm touching the solder pads on which the motor is connected. Oop, I had it for a second. So I probably have a bad solder joint. That's no good. You don't want that. Give me just a second while the soldering iron gets up to temperature. Now we're going to apply some fresh solder. I'll do the one that I did because it's probably the wire that was broke. I had to feed the broken piece out of the hole. If you ever take a rotor assembly apart, they usually have 2 to 4 holes. Like there's a second set right here that is just about a ½ an inch away from the original for multiple items most likely. But only the tip of the wire sticks through, and then the solder holds that to the rotor pad or the circle of copper. It's very possible that the tip of the wire wasn't long enough, or it cracked when the solder went on because the wire is so thin. So, let's see if that's any better. Trying to keep this so you can see it and I can see it, because if I sit down and look, all I see is the edge of the screen. Still nothing. Okay. Just adding a little flux. And we're going to to try it again, but I'm going to add solder to the original pad as well. See if we can get some connectivity here. Because once we get connectivity, it should technically work. Then we just got to figure out those two wires right there that come out of the base. Check the power on them. I made the contacts a little bit larger across the arc of the copper. See if that helps with a better conduction rate, I guess. Let's find out. Yes, look at that. Yes. Yes, there we go. Now these two copper rings enter in the outer ring, which are 3 fingers wide, and there's a dark spot between them that separates them or isolates them. They will have continuity if your motor's good. If your motor's bad, meaning it's open, the continuity would be OL. If your motor's shorted, the continuity would be super, super, super low, and if you have a meter with a tone on it, it would beep at you saying that you have a short, or that the ohm rating is so, there's almost no resistance. So now we'll try it again. I'm just going to try without a belt just to see if the motor spins. Yeah, the motor is only spinning again when it hits those pads. One thing I don't like about the rotors that Lemax uses is for some reason this happens quite often, where it loses conductivity. I'm going to try with a power generator and just touch the pads and see if I can get these things open and close. So they're upside down. My next option is going to be trying to resolder them in different spots, or just coat the entire copper area in solder. But we need to get it to conduct electricity. That's where the problem is at the moment. So turn on the power supply and try not to get too tangled up in the pieces. I'm not getting anything. That motor should be spinning. this is definitely throwing a monkey into the wrench. I'm not getting good contact. I'm wondering if this rotor track is just bad, because this outer ring of discoloration is where the copper is completely eroded away. I'm wondering if the inner finger that touches in here, and I'll show you in a second closer once I get the extra dielectric grease off. I'm wondering if that's the problem, that the rotor is eaten up and I'm not getting good connection all the way around the ring, which is why it only spins the motor 1 or 2 revolutions, because that's the distance it travels across the solder pads. So, excess dielectric grease is gone. Bring it up to the camera for your viewing experience. So, if you look, you'll see it's nice and shiny copper, but this outer ring, because it's got copper, that is eaten through. That's why it's a different color. The inner ring, you can see the copper rings are fine. They're copper. This one has one really good copper groove, and then the outer edge is barely got some here and here. So I'm starting to think that either the fingers are out of alignment, or this has very little conductivity due to the fact it's been eaten away. So, since at one point this did work, I'm going to assume the fingers would be aligned, but you can turn them with this screw. So this is the outer ring, the one that's eaten away, and that's the inner ring, the one that's totally fine. So I'm going to clean off a little of the grease and see about turning it just a little bit to see if I get better connection. I turned it just a hair. It has a stopper to prevent you from turning it too far, but it does have a little bit of movement. So I'm wondering if by turning this way, it might grab more of that outer ring that is eaten down, or allow the finger to track better on the inner ring where there's more copper. So let's find out. They use this style of rotor on most of the Ferris wheels, and the Ferris wheels, they always get chewed up. But basically it's just a disc of copper that spins on fingers that on this one are made of brass. And what it does is it just transfers electricity onto something that's moving, because you can't have the wires do it, because they'll just twist themselves into a knot and then break. There we go. And I'm just going to use this again for the centering. I'm not going to screw it down. That. Still nothing. Possibly moved it too far, so I'm going to move the fingers back. Checking the solder joints. There's got to be a reason why I'm not getting good power up top. This one has a bigger solder pad, but that doesn't really mean it's a better connection. So the wires look good. They're not pinched. Looking down inside the base, I don't see any cuts. So there we go. Yep, it's still only spinning when it touches those solder pads. So, and it's not spinning all the time. So, definitely we're experiencing a connection issue. What's probably going to end up happening is that I'm going to clean the entire surface with rubbing alcohol and then run a ring of solder all the way around. The only other option I can think of is a bad motor. So, looks like this is going to be a whole lot of trial and error. The only joint that's between the two is this rotor, and I'm thinking that the copper on the outer ring may not be fully connected due to the corrosion and erosion of it. Worst case is the bad motor. Got to take the whole thing apart, replace the motor real quick. Not a big deal. Right now I'm just turning it in a light. I'm looking at the copper to see if I can see any breaks. Something that would impede the electrical flow. The inner ring's starting to wear too, right on this inside edge, right here where my finger is. And it's all pitted right there. So the copper rings are deteriorating. They don't last forever. And then when they go out, that's when you have your biggest issues. They don't sell spare parts. I'm sure you can make one though, if you have the materials. You can just get a copper board. They sell them for making your own PCBs. And then you use an etching compound and you can remanufacture this little square board. So I am going to clean this whole thing down, and I'm going to probably unhook the motor or cut the wires and test the motor directly and see if it actually spins. That way I can get rid of the motor as a potential problem. I'm leaning towards it's going to be the actual copper rotor assembly. So let's test the motor right now. Need to hold it up because if it does actually spin, oh, never mind, if it spins, it's not good, no belt. So she's spinning. Let's put it up to the full power it's going to get, which is 4.5 volts. Okay, let's put the belt on. So. No, motor is not turning and it's making a funny sound. So, where's that original belt? Over there. Let's just, again, make sure it's not the tension of the belt. The new belt's going to have a little bit more tension than the old belt. Sometimes too much tension prevents things from spinning. So let's try that and see if I can get it to rotate. Look at that. So it is rotating and bringing the characters in. So I have my hand under it to hold it up. There we go. And then just turn it and it should swing them back out. Thinking the motor's going too. The motor is making a clicking sound and I won't go to full extension. It's a brand new motor. Come with super long pigtails on them. Want to see how much amperage this draws compared to the original motor. I think some of the grease got in the motor and that's why it's making a very quiet clicking sound. I do believe the motor is going. Now, that motor free float, meaning no belt, was pulling 0.05 amps. And under a load, with the characters hooked up in the belt, with the black belt, it was pulling a fifth of an amp, or 0.2. Without that, it was pulling 0.09, 0.1, or a tenth of an amp. This with no load is pulling 0.01 amps. I'm going to use my finger as a load. I'm going to press on it, and I'm pulling now at 0.07, and I have the motor stalled, meaning it quit spinning. So it went up to 0.08 that second time I just did it. So I believe this motor is getting weak, and that's part of the problem. The other part is I still think we're having a power transfer issue from the fingers to the board, possibly due to the corrosion that's eaten through the top layer of copper. The material underneath it should still be conductive, but it's probably not as conductive, and with a weak motor, it's just a all-around failure of situation here. So I'm going to go ahead and take this apart. You saw how it's already done, 2 screws. I'm going to take the motor out, put this guy in, same motor, and then I'm going to clean the copper with the alcohol. We're going to do another test to see if it functions, and if it functions, great. If it still is intermittent or choppy, then I'm going to coat the entire board in solder as a conductor. The nice thing about these fingers is even though the solder is slightly thicker than the copper that's on there, these are spring fingers, they will compensate for the imperfections of the solder, meaning the lumpiness if it's not smooth. And that's why these are springed. It's all one to keep tension on the board, two is so if the board has an imperfection, the fingers will ride whatever the imperfection is, and hopefully not lose contact. It doesn't really spin fast enough for it to lose contact. It'd have to be spinning really fast. So, and if it spun that fast, it'd probably just throw all these little balls off. So anyhow, So instead of watching me do this for the next 30 minutes, I'll pause it right here and we'll see what the result is. So step one, change the motor, give it a whirl. I'm going to give it a whirl with these versus using the copper just to make sure it turns. Then I'll try it with the copper. I'll solder these in. I'll pull the solder off of this board right there, feed the new wire through and resolder it, and then see if those will make this motor spin. If it does, and there's not a huge load draw on my machine, then we'll probably leave it as it is. But if it has intermittent, meaning the motor starts and stops like it was doing before, then we'll just coat the entire thing with solder and see if these will give me a better rate of conduction. So, shall return in just a few. Okay, still playing with this thing. Trying to get it to work right. It is a little frustrating, but got the majority of it fixed. Stuck on one final part. So I'm going to zoom in so you can see that the drive system actually spins like it's supposed to, but at the same token it spins, but these still do not move out. So first I'm going to do is I'm going to zoom in so that way you can watch it go in a circle. Now, to ensure that you see that it's spinning, like I always do, the wires won't get caught in anything, they just slide around. Notice it's changing directions, but if you notice, you haven't seen any of these pop out the sides. Wrong way. Right way. So none of these are moving out. So, turn that off. Let it do its power down cycle. It takes forever. It's like 1.5 to 2 revolutions. The clicking sound, still haven't been able to find it. I'm still looking for it. But I think it's the fingers on the new rotor. Because the old rotor had too high a resistance. For proof of concept, I soldered on a piece of copper braid. It did work, but this didn't spin fast enough because the resistance is too strong. I was going to make a new rotor, but I found one. Actually, I have one lying around. The only difference between the one I found and this is this hole is bigger than the one I replaced, so I cut that out to make it the same size. So, but that new rotor slightly thicker, so I'm thinking the fingers are clacking over the solder joint, like right here on the new rotor. Unfortunately, I can't see through the plastic, but I will take it back apart to try and solve that. There's a secondary click, which is down in the base, which is a relay. The relay is what changes the polarity on this. It goes click, one way, click, the other. Changes about every revolution of the whole mechanism. But after a new motor, because the other motor is bad, a new belt down below, and a new rotor, I now have good power. I got 4.5 volts up here on the rotor. Probably only getting about 4 volts to the motor because the voltage drop. There is not a huge amount, but there still is a measurable resistance on these rotors. The inner ring is about 1/100th of an ohm, and the outer ring is about 2 to 3/100ths of an ohm. Because when you measure 180 degrees out. Since the fingers that run on this, that make these nice little finger grooves, are 180 degrees out at one point between the solder pad and the other end of the rotor. So the new rotor is much lower resistance than this one. This one's got the 1/100th of an ohm on the inner ring, but this outer ring is in the 30s and 40 ohm, which is way too high to conduct 4.5 volts of electricity. So, but after, I don't know, bashing my head on this thing for a few, probably a half hour, so a few minutes at least, I finally found the problem. Now I just got to figure out how to fix the problem. So what happens is this, with these 3 screws, one here, and one over here, these little guys right here that are in this slot. These are alignment or timing screws. It allows you to turn this to preset these at whatever distance. It has a, I don't know, 5 or 6 degree arc of teeth that are driven by this motor. Before this motor hits the other end, it clicks down here in the base and reverses this polarity. Before it hits the other end, it does it again. It goes back and forth in this little arc. And this arc is only from here to here. So it's very, very, very small. So the timing has to be perfect, or else you'll break the gear. And that's the impossible one, which is a $20 gear. I've adjusted these, which you got to be careful adjusting, because if you adjust them too tight, they will not allow the top to move. Found out the hard way. So you got to adjust these just enough that they still slide, but they don't just drop. So it's about a half a thread, maybe, above the plastic on each of these 3 screws in this small groove. So as this moves, which you can see is tapered and pushes on these. So you also got to make sure that when it goes to its stop position at either end, it's not stuck in these 2 points on any of them, which they'll all be the same because they're the same distance apart from each other. So I set it here, which means that these guys start in the position like this, and they're supposed to collapse and then go, which they do, for about 5 to 6 revolutions. And then they just quit moving altogether. And you think it's very simple. Oh, it's a timing issue. You didn't adjust these right. Yeah, I thought the same thing. I was wrong. The problem is, this has got a clutch gear. The clutch gear isn't engaging under stress. So, this gear right here, that looks like it's split, because it is a clutch. So when it rotates, the top can rotate separately from the bottom. What's happening is one direction, the closing direction, it pulls them in really fast. In the opening direction, this top gear spins multiple revolutions before engaging the bottom half, and then by the time it does, this reverses polarity. So when this reverses polarity and these guys are pulled in, the clutch slips so it doesn't break the teeth. That's what it's designed for. And then what happens is it's at a point of diminishing returns, meaning that I start out here, and after about 6 revolutions, they're just like that again, although the gears are rotating. This gear is not rotating enough to turn this arc anymore. It's only rotating about a tooth because this clutch gear is slipping. So, and I just figured that out before I turned the camera on. After watching this thing for literally a half an hour, I'm just staring at it, trying to figure out what's going on. The problem is the clutch gear sound like that while I'm working on it. So it's away from my vision. After thinking about why these guys aren't coming out, I decided I better watch the gear pack, which of course spins all the way around. So I had to set this where I could see it for the timing of switching directions when that goes from counter to clockwise. So I kept rotating this enough to watch the clutch gear lift and disengage, only in the out position. I said, okay, so it's weak in one direction. Let's make it weak in the closing direction, which is the direction of gravity assistant. So I reversed the polarity of the motor. So that means it should be stronger on the outside because I'm now turning it the opposite direction. Yeah, no, it doesn't do anything. The clutch still picks up too much resistance from these 8 balls being swung out. So there's too much resistance on this plate, which is pushing on this gear and then backtracking the 3 gears total to the clutch. So I am going to try and locate a clutched gear. They're not very common. I know that there is a new piece this year, I believe it's the Headstone Mill, that uses that same gear, which I said in the video was kind of unique because what it does is it protects the other gears from getting their teeth stripped, which is a very common issue, especially on this gear here, to happen. When I say this gear here, it's the impossible gear. It usually breaks the thin teeth. So now we're at a point where I can do a couple of things. I'm trying to find the OEM replacement first, another clutched gear. If I can't find the gear, I can try and pin this gear. Pinning it means I'm just going to prevent it from slipping. Glue a physical pin, where you drill a pin through and then set it in place. And if that doesn't work, I was going to look for a tall gear, which is a solid gear, to replace it. And then I have to stress test it, because this clutch gear, again, is designed to protect all the gears from stripping themselves out if it reaches either end of the arc. So this is a piece that requires correct timing, hence the reason you're supposed to turn it off before you unplug it or kill power to it. But it doesn't have a timing indicator at the top. The timing indicator is how many revolutions it makes inside the base. So this top makes about 1.5 to 2 revolutions to turn itself off. That's when this base resets. And I've turned it off a dozen times, and it's usually between 1.5 and 2 every single time. Unless you happen to turn it off right as it's at the reset point, which has happened 4 or 5 times, where I've turned it off and it literally just went and stopped. And that's because it was already at the reset point in the base. So the timing mechanism for this that controls when this actually kills power is down here. This timing mechanism, which is also controlled down here, it just counts how many turns. That's all I can figure. Every 360 degrees, swing them out. Every 360, pull them back in. Or it might be 722 revolutions. But so if you have the Octo-swing and you're having a problem where these guys aren't coming out anymore, and your motor's good, you replaced it, or it's not bad to begin with, your belt's good, everything's spinning like you saw here where the drive pulley's spinning and all your gears are spinning, but you notice these gears are spinning super slow, this clutch gear is probably your culprit. So, and at the moment I'm not quite sure how to replace it. I'm trying to find a screwdriver, the one I was using, so I can open it up, and there it is. I took the top back off. I put the top on, soldered the wires, made sure all the lights were good. Then when I saw that I was losing my swing, I desoldered the top and pulled it back off again. So, but I will open this up so you can see the clutched gear up close and personal. Yeah, there's a lot of screws you got to take out. You got to take out the 4 around the plate and then the 3 in the center. The 3 in the center is what keeps this pushed down so it doesn't lift and come off of those fingers that transfer the electricity from the fingers to the rotor. Here's the new rotor. See, here's the back of this one, which is the original. You can see it's tan. The new one's green. Because the new one came from Mr. Christmas, and the copper pads were actually there to conduct electricity in multiple items, not just one. So we'll pull the top off and slide this bad boy out. So here is the clutched gear. You can see I can spin the one and the other one doesn't turn. Pretty nifty, huh? Problem is it's not staying engaged when it's supposed to grab. Because it's a magnet. These magnets are not doing their job. So I gotta figure out how to make this clutched gear, or slip gear, I don't know what Lemax calls it, or the manufacturer that makes them for Lemax calls it. I gotta figure out how to make this thing stop slipping so much. I'm not sure if I change the neodymium magnets, if that made a difference. These are cut magnets, which means they're going to be kind of hard to replace. They're not round. I don't know if I just glue them together and make it a solid gear, if the vibration is going to cause something to break down the line. Like I said, that's the most common one to break. This and this and this and this and that one are standard. So there's the new motor. Because the old motor worked intermittently, and it would go clunk, 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 because grease got inside the armature, which you can tell since there's a buttload of it that they like to overdo their stuff. So, but there it is. I'm not sure if this sticky stuff was supposed to be glue or not. So I think my next step is literally I'm going to glue it together. I'm going to glue the magnets into the plastic, let them sit for a day. I'm going to use some really strong stuff and then try it again. But this is the problem I'm having with these. Now that this is out, I can reset the timing. And how you reset the timing is when those are loose. If you turn this outer ring, you can see that they swing out. Now if you were to just clunk those 3 screws, tighten them all the way down, this motor will burn out real fast because it's getting 4.5 volts but can't turn. Unless this clutch gear slips, which it will, but it will not slip fast enough to where you won't cause an overdraw on the motor. So, but this is what I've been doing, is I've been setting this out, putting the gear back in, which the axle shaft's right there, like so, and then letting it do its thing. After 5 to 6 revolutions, they go from out to in and stay in because of this guy. So that's where we're at. I thought this would be a relatively easy one to repair just because it's pretty basic, but having a slip or clutched gear fail is something unique. So, and then let's see, pull that through. There's the new rotor. You can see this rotor is all brass. It's not a blend like this is a copper plated brass, and this, you can probably maybe tell it's kind of jagged. I used a Dremel sander to sand the hole slightly bigger. And then there's the solder joint for this one, and then the solder joint for the outer ring is on the back because this outer ring protrudes through the PCB board. So, and I think this finger is the clacking over this lump because that's the wire. I made it as thin as I could without worrying about it wearing down or breaking. And if you run it like this, there's no clunking. And you got another impossible gear here as well. So, but that's where we're at. Also, if you do have this piece, these do not roll. They have flat spots on the end from wear. It's because they glued them in place. They don't move. They're literally just guides. They're not roller guides, which I thought was weird. I would have figured if they rolled, there'd be less wear on them. But hey, I'm not the engineer from Lemax, so I just fix it. So, but anyhow, so I think my next step is I'm going to try and just glue the magnets into the respective sides to make sure that it doesn't lift a magnet out of its slot, and see if that's my next course of action to fix this. If that doesn't work before I pin these together, gluing the magnets to each other, I'm probably just going to try and find a set of gears with this ratio and glue them together to the same height as these and stick it in. Because again, my concern is the rotating mass might separate the teeth on that gear on that piece. I could be wrong. I don't know. And most everything I do for the first time is always trial and error. So it's going to be trial and error on this as well. I'm trying to make it trial and non-error or work. That'd be great. Right now I'm just cleaning off all the black debris. The black is a mixture of grease that's getting hot and, well, metal shavings. Yeah. Like I said, this outer rotor was worn down to nothing. The outer ring. So stuff like that is what causes the dirt on stuff like this. Also, the two magnets slipping on top of each other are grinding the faces down. But anyhow, there's the update on this. while waiting for stuff on this to come in, like my motors, since I ran out. I've been working on a few other ones, which will hopefully be up soon. Probably way before this video is done, to be truthful. I don't film in the same direction that I post them. Usually because I start, and then I have to wait 2 weeks, so I start something else, and then I have to wait a week, and I start something else. So, but, yeah. So, but, you know, if this gets done, and if you have any suggestions, well, let me know, because I am not sure how to fix a magnetic gear and make it work like it's supposed to and overpower gravity, because I think that's my problem. It's just the inertial weight, gravity pushing on all 8 of these pods. These magnets are just too weak now. And I could be wrong. It could be that it's jumping out of its socket, and that's why this one keeps coming out of the base, is because there's a problem. Oh, and if that is the cause, that it's not glued in and it's jumping out, make sure you glue them in the right polarity. Because it just flipped, which means I would have glued it in upside down and they'd repel and they wouldn't work at all. So make sure that if you do have to glue them together, that you know the polarities. So anyhow, I'm gonna glue this. I'm gonna put a drop of this in there and then shove a toothpick through the hole so I don't clog up the hole, since the axle has to go through it. And we're going to see if that takes care of the problem. Anyway, we'll be back in a little bit here, probably tomorrow. I'm gonna let this harden overnight. So this is just a quick update at 20 minutes and let you know the process of going through it all, from a rotor, motor, belt to now a slipping gear. So, and now you can see kind of sort of how to get some stuff done with the gears, how to get a rotor. I still may make a rotor just to show you how I would make one, instead of just finding one in another parts house that actually has decent resistance. So I might take this, probably will when I have some free time, and make a replacement. So if you have one that's got a ground down rotor, you can make it at home for probably less than $20. Because finding them is going to be really hard, unless you get a parts house that has them in it and it's not ground down. So, but anyway, shall return shortly. All right, welcome back. After literally weeks of playing with this intermittently in between work and the holidays, because it is the first week of the new year, I finally think I got this thing working. So these are the light wires, of course, are up top. I'm going to move these out of the way so they don't touch each other. I'm going to stick them into the screw holes so they don't get caught in the moving mechanism. So we'll turn it on. So, I'll recap real fast what I had to do. That gear I showed you that had the slip magnet, yes, I had to glue the magnet back in. Very important that the magnet gets glued in if it breaks free. That is one issue. Second issue that's been driving me nuts this whole time, and why this thing would not open, and it would open, close, every time it gets smaller and smaller to the point where it just wouldn't move anymore, although all this was moving. I got a defective motor. The motor that they sent me, or the motor I ordered, let me rephrase that, I ordered a whole bunch. This guy, this is the one that was in here just shortly in the video earlier. This guy is bad. So I changed it out to the 2-pack I just received. You can see the shine is different. One's dull, one's shiny. And yeah, that was the biggest issue. The biggest issue I was having on why this thing will not open and close with the voltage it's getting, because I am getting good power. they sent me a bad motor. Well, they actually sent me 16 of them because I ordered 16 of them. So what's happening is the motor is supposed to spin at 11,400 RPM. And the motor they sent me is fluctuating between 3,000 and 10,000. It just accelerates and decelerates. So when it's collapsing, when gravity is helping it, it's spinning faster. But when it tries to open, it can't open fast enough for the clicking you hear to switch polarities. That clicking is the polarity switch. When it clicks, it reverses the motor, goes out, and it is what it is. So, new rotor, new motor, twice. Glued the magnet. This was a very hard one to chase down, mainly because I assumed, and that's what they say when you say assume, that the motors they sent me were good. So, new lower belt. New upper belt, which is a slightly looser belt because if it binds and it slows it down too much. And then it's in those Akukai packs, or however you pronounce it, it's one of those tan belts, which is not as rigid as the black belts that I use from Skull Crane. So this upper one is more sensitive to pressure than the bottom one. And that's probably because this is all the moving mechanism that swings it out and in. Has to slide these rails back and forth. A lot more stress, and then the stress of a too tight belt, well, it's just too much for the little guy to handle. Whether it's the slow motor or the fast motor, doesn't work. With this, you definitely need to use the 11,400 SRF 300 CA motor, which right now are $8 for a 2-pack on Amazon. So, links will be below. But, next, gotta solder the wires onto the top, right here. Get that put in, make sure it all lights up, and then glue the head back on. So, yeah. You've seen me solder, so I'm just going to solder the wires on real quick, align it. I got to heat shrink these. When I re-splice the motor in, they're just on loosely, so I could test the motor to make sure the motor works like it's supposed to. So, and it is a resetting piece, so if you unplug it, you can damage it. You need to turn it off from the switch, and it will reset itself, generally. So, it's off, and done. So, alright, well, bear with me for a minute, so you don't have to watch me for the next 5-6 minutes soldering. My soldering iron's now on. Solder the wires in. I did test the wires with a voltmeter, which is right there. The white wire is negative, the yellow wire is positive. I already fixed the loose or broken LED that was in there. I resoldered it back on to the negative to the white and the yellow to the positive. So I just need to solder these on. Now, these originally were soldered up in the center, and that's why it broke that light free. I think to make it slightly easier, I'm going to either solder it off to the side. No, I'm going to solder it in the center, and I'll tell you why. The reason I have it soldered in the center is so as this disc rotates, if it's off to the side, it doesn't catch. So it's going to have to get resoldered in the center. If it was soldered off to the side, it would give you slightly more movement to allow you to fix this if you have to take it apart. Well, screw it. I guess I'm just going to work on it while I'm here. I have not forgotten about the heat shrink. With the amount of slack in these wires, I'll be able to lift this top back off. Now, I guess we'll take care of it real quick, just in case. Now, usually I use a heat pen, but I don't want to wait for it to heat up, so I'm just going to quickly hit it with a lighter. Just move the top out of the way real fast. That's one. That's two. That fast. Heat pen or lighter works great. I would have heat shrunk it with this whole top off when I soldered it, but I wanted to test it. And then if it didn't work, I could, if I got another defective motor, I didn't have to cut my heat shrink. I could just desolder the solder points and then call it good. I'm trying to line up the 3 holes. Slightly more difficult than it appears. There's one. There we go. There's all 3. So yeah, it's a good thing I heated it up and did it there, because it was actually a little bit harder than I thought it would be. Alright, so add a little fresh solder to the wires. Use some tweezers to hold it. So try and bend the wire a little bit so I can solder better. Oops. Let's try this again. It's kind of fidgety. Wire moved and it soldered across both sides of the LED. Luckily it wasn't a good solder joint, so I can do it again. As soon as I saw the wire shift is when I just unapplied the heat, so the joint was cold. That's why I was able to tear it off with a pair of tweezers. Alright. Huh. So I don't like the wiring that Lemax uses. It has a tendency of breaking constantly, and it did. There we go. Yeah. This is the biggest problem with the wires they use, is once they solder them once, they seem to get really brittle. And they don't like to be soldered again. Even stripping them down, they have a tendency of breaking. See if I can... No. Can't even twist them. So... Alright, so I've twisted the white wires together, stripped off fresh. So I'm going to tin them and then stick them on. With them twisted together, they'll act as one strand of wire, not two, and hopefully not separate or break. So now they're soldered. Now let's see if I can get the LED on them. Might have to do the same thing to the yellow wires as well. There we go. So just to make it easier, I'm just going to do it that way. And it's not a very good solder joint. Don't like it. I'm going to do it again. There we go. All right. So they're soldered. Let's make sure. Oops. Let's make sure everything works like it's supposed to. Since this thing has been kind of a pain. Now remember, this isn't screwed on yet, so it bounces around, and it looks like this lights out. So that's one of the reasons why we wanted to do this before it's glued on. So it's this one right here. And the pin looks like it has broke off. Can't tell. Pull the light out a little. No, it's the solder joint broke. So need to fix this real quick. First thing I'm going to do is spread apart the leads, because the two leads are touching each other, and that would be a short. That would be bad. Flip her back over. I need to strip some wire off because there's only one strand sticking out of the yellow on both sides. So I need to untwist the wire a little bit from both sides. So one twist. There we go. So I can strip them, solder them, and then solder them back to that light. This is why I test things at different stages to make sure that everything works like it's supposed to. Because if I would assemble this and not test that motor a million times to find out why it was losing signal, one, I wouldn't have known it had a bad motor, and two, I wouldn't have noticed the magnet separation on the slip gear. The magnet is very important. A lot of units that have motion that changes direction has like a micro switch that tells it to stop sending power until it's ready to reverse polarity. This does not. So that motor is still spinning in the same direction even though that the arc of motion is complete. So what's happening is the magnets are doing that, and then they, like a clutch, and then they lock. And then it reverses. They're locked, and when this one stops, the top one just slips on top, and that's what those two magnets are doing. So those two magnets are very important. And what was happening was the gear was lifting because the one magnet would pop out. So it was doing this. So that's why it's important to test it along the way during the repair, because things like this will always sneak up on you. We're going to tuck those in a little bit better too. Okay. Now we should be able to solder it on. Now that I can see the connection by moving the white wire and the dab of glue. So I'm going to tin the LED. Like that. These goggles or magnifiers work great for this small stuff because you'd be really hard pressed to see it if you have bad eyes. You know, I wear glasses all the time, so technically my eyes are already bad. And try not to touch your skin with that. I'm going to tell you that's really hot. LED fell out when I was trying to solder it. Too much pressure. Oh, solder fell off the thing. Ugh. Try not to breathe the fumes. Technically it's toxic since it's lead. That's why when I'm soldering to the side, I'll talk, but when I'm soldering from above, I'll blow it out and away and then not talk. So that way I don't get any more lead in my system than I already have. first, tuck the motor wire real quick before I forget. So, and gotta pull these up. Set them back on top. This is a kind of an annoying puzzle game, I'll tell you that. The three three holes are not equidistant apart, so you can't put it on any other way than the only way it fits. There we go. 365 attempts later, it's on. Alright, what I'm going to do is, to prevent the top from wobbling, I'm going to put one screw in here just to keep the top from trying to bounce off of the pegs. Alright, take 17. No, still doesn't work. Alright, I'm going to take the top back off so I can work on it again. Apparently it's a loose, I bet you the other joint is cold and it's cracked. So, probably should have hit them both while I was in there. Ah, and now I know why it's off, the three holes are off-centered. This is the entrance to the ride. So they want the lights, 1, 2, 3, centered with the entrance. So, I guess if I was more observant on that fact, I would have noticed that. So, for you, quick tip, if you take it off, 3 lights, put the one light directly above the wooden steps. So, alrighty, well, give me a few minutes. I'm going to take this apart again, try and fix that light again, and see if we can get it to not flicker off and on by touching it. So, excuse me, hopefully when I come back, because I'm going to pause it since I've already wasted, you know, almost 30 minutes now on this piece alone. Hopefully it'll all be glued together and ready to go. Then I can send it back to its owner and work on the next piece, which on my bench will be the Swan Ride from Lemax, but not saying that's going to be the next video because they are not posted in order of repair. So, and that's due to timing of parts. So, all right, be back shortly. All right, finally back together. I had to replace the LED. Here's the bad one. It got a burn and it turned black, so it doesn't work anymore. So probably the heat of the soldering iron was too much for it, and it destroyed it. And then I'm gonna put the cap back on. I'm gonna put itty bitty amount of hot glue around the edge, just barely squeezing the trigger, just enough to get a small dab. There we go. So we can have the light deflector. Oh, the new LED I did glue on the bottom as well, like the OEM was, so that way it doesn't fall inside. So here it is. Finally, after a long time, we kill some lights. Octopus is glowing. I'm going to try and tip it without smacking anything. You can see the purple lights and the green lights. It actually looks pretty cool in the dark. I like the octopus, the way it pulsates and it's somewhat translucent. Turn the volume down. And lights coming back, and no. Alright, so end result. 2 belts, bottom and top. A little bit better belt on the bottom, a little bit weaker belt on the top to prevent binding for the rotating mass. 1 new LED, a new rotor board, which is new to it but used in general. 2 motors, first one being the original being bad, the first one new, replacement defective, and then the second motor works. And re-gluing in the magnets on the slip gear. So, a lot of work, a lot of troubleshooting, a lot of chasing I did off camera to realize it's a defective motor. And the real way I realized it is while I was fighting with this and waiting for a gear pack to come in case that slip gear wasn't going to be repaired, I worked on another one and the motor didn't work. And I'm like, that's weird. And I put another motor in it and that one didn't work. And then I just checked all 16 or the remaining of the 16 motors. And sure enough, they all did not spin or at the right speed, or they didn't turn on at all. So, heck, one of them was shorted right out of the box. So, sometimes these Chinese motors are great, and sometimes they're not. So, that is the Octo-swing repair. A very long video. Very sorry about that. Very entailed. Lots of small issues causing one large issue, and then of course getting defective parts never ever helps the situation. So thanks for watching. Till the next one, which hopefully won't take forever. I'll see you then. Thank you.